All right, guys, fourth and final video here, hopefully. What I want to do here is kind of give you guys a shortcut to problems that are like the first problem, right? Where we've got an exponential problem where we've got an e going on. So I want to review our steps to solving these. Step one, always take that first equation, that differential equation, and integrate it so that we get an f of x instead of an f prime of x. Then we need to go and get our c value by using our initial condition. Once we have our c value plugged in to our f of x, we can now find any other value that we need to find. In this case, we're looking for the value at f of 0. Well, can't we wouldn't it be a shortcut if we just could look at the problem and know what the c value is? Well, in this case, I think that we should just know what the c value is. Because see, the integral of negative 3 e to the x is just going to be itself plus c, right? So the integral of negative 3 e to the x is negative 3 e to the x plus c. And the integral at 1 is negative 3 e to the 1. There's really a 1 there, negative 3 e to the 1, plus 12. So in this problem, isn't the c value just 12? We can skip all that integrating stuff, and we can just say, hey, f of x is, where's our mouse here? F is negative 3 e to the x plus 12. All right. So now, since we're looking for f of 0, we can just go to 0. Well, e to the 0 is 1. And we just have negative 3 plus 12 equals 9. F of 0 must be 9. We were able to figure it out because, well, the integral of this is itself plus c. That number right there must be our c value because this is our itself part, and that must be the c part. So that saves kind of the first half of the problem. So whenever you can find the c in a easier way, go for it and plug that in for your f of x, and then you're good to go. And if that shortcut doesn't make sense to you, no big deal. You can just go through the steps of find the integral, use the initial condition to solve for c, and then substitute that value the x value that you're looking to find the f of that x value.